Hello guys, we are going to understand today question that we have 1572 matrix diagonal sum. Okay, so this question is very important because this is easy question and this is based on array, right? So this can be asked in any product based companies. Yeah, so let's understand this question. So we have given this question given as square matrix mat, and we have to return the sum of matrix diagonals, right? So the only include the sum of all the element on the primary diagonal and all the element on the second diagonal that are not a part of the primary diagonal. Means, just for example, this one, right? So we have given diagonals, right? 1 we have given, 5 we have given, and 9 given. This, let's suppose this is a primary diagonal. Okay, and another what we have given, second we have given 7 and 5 and 3, right? So this is already present in this diagonal, right? As you can see, so this is the diagonal in which it is already present, right? 5. So when we are going to do the sum of this, right? So these 5 should not be counted. It is 2 times going to count, right? We have to escape this one, right? So we will take these 3 and this 7 and we will not count this one, right? Let's suppose what I'm trying to say. So first diagonal is 1 plus 5 plus 9. This is the sum of first diagonal, right? So let's we can say what 15. Okay, now second diagonal what we have 7 5 3. So this time 5 is already calculated, so I will not use that. I will directly list 7 and 3, and that is 10, right? And if we will do the sum, it will come 25, right? And this should be your output. Okay, so here we have given a square matrix first of all, and our task is to return the sum of elements on the primary and the secondary diagonals, right? So without counting any element, right, twice, it occur on both the diagonals, right? That's why we have escaped this one and we have done the sum, right? And we have returned this one, right? So what is our approach will be, right? So first of all, we will iterate every element over the diagonals, right? And then we'll try to implement this one. Okay, so first of all, as we can see that the element along the primary diagonals have the same row and columns numbers, right? And so all the elements of the matrix, right? Let's suppose this is a if you count this one, these number, these and these are if this is I, let's suppose if this is I and this is J, right? So numbers are becoming at what? A, I and I we can also say, right? Because I and J are equal, so I can put like this also, right? So I and J, when it is equal, right, then this is going. So I will not take 2 loop here because it's not required for this one, right? I will take 1 loop and will iterate like this only. Okay, so I can arrange the range of I will be equal 0 to n, right? We can say. Okay, so we'll go to like this only. Okay, so better let's understand going through the code, so we'll understand easily. Okay, so let's coming back to here. Let me increase little font. Okay, so now we are here. Now what we will do, we'll do the implementation to understand. Then let's suppose we have given this diagonal matrix, right? So this matrix we have given, so from the matrix what we'll do, we can find the length, right? To find the length of the matrix, what will happen, your size is the matrix, what will happen, we have matrix dot, will go do length, yeah, this one, and we will get our length, right? Now what we will do, we'll create we have to find the sum, so I'll take int sum as a initial value as a 0, and we'll do the sum on the loop, that will see later. Now what we have to do, we will go to the for loop, we'll start from the first I equal to 0 and I should be less than n and I plus plus, right, as I told you. Okay, now what we have to do, we will to find the all the diagonals, right? So first element will come at what, which position? The first element, that is it is coming this one, it is at 0 0, right? So as you know, if we will represent a matrix, it will come at 0 0 this diagonal element will become at 1 1 and another will become at 2 2, right? So that's why we will take this I 0 0 and this 0 0, okay, and we'll see about this one. So let's suppose we have given how many elements we have total here, 3 into 3, for 3 into 3 matrix, how many element will be? 9 element, right? So if n is 9, just for example, if n is 9, so for 9, okay, so the if this is n, let's suppose this is n, because if we'll calculate the size of this one, this element, right, it will become what? 3, because 3 element is in the row. And if you'll also go for the column, there is 3 element, right? So either of this it will check, you will come a 3 only, right? So if I'll let's suppose what I'm trying to say, so this is the matrix we have, right? So we have already completed this one, and this is at what? All are equal, I j j I sorry, I into I is same, right? It is coming I equal to I, so I a at I and I are same, right, for this one. Now we'll find this this diagonal, right, this diagonal. So to find this diagonal, what we have to do here, we have what element? 3 will do 3 because we are going to find this one, right? So 3 minus 1 I will do for first one, and then minus I will take 0. Let's suppose if this is 0 1 2 like this, okay, so it will become what? 2, that is correct, right? This is correct, and another will take what? 0. So 2 0 is this element, 2 0 is this element. So I will take for this one, as you have seen, I will take n minus 1 minus I, right? This have we can write I like this, we'll use that. So if you'll find this one, right, this will come same, right? How will come? If I equal to 2, right, or I equal to 1, in that case what will happen? We'll get this element, right, this diagonal. So n means what? 3, 1 minus 1, now it will become what? 2 minus 1, it become what? 1. So we'll move to this element, right, this one, this element. So it will become what? 3 minus 2 is 1, and then another will become what? 0. So this is the index. Second index will, if you find this index, it will become what? 3 minus 1 minus 2, it will become what? 0 and 1, correct? 3 minus 1 is 2 minus 2 0, yeah, 0, and this will become what? I is become 2 now, right, like this, and this is the index which it will become 1 1, sorry, like this it will become 1 1. So we will skip this one because we have already counted this one, okay, sorry. Now you got the positions, right? So now what we have to do here, we'll find this matrix, right? To find that, we have sum, we'll do plus, right, and here we'll add the matrix elements. So now we have matrix at what? I 1 0 0, for 0 0 1 1 and 2 2, it will become I and I, right? Now similarly we have to find the answer from the second diagonal, right? So sum plus equal to, we'll find matrix, sorry, I have taken the space, I will take matrix at what we'll have to find. First we'll take n minus 1 minus I, and then this will become I. So you can also choose, you can also take this one first and this one second. It's all dependent on me. I have taken from downside. You can, if you want to take from the upside, you can take like this one, right? Okay, you got it. Now let's suppose this is done, okay. Now what we have to do, so now let's suppose if there is if n is odd, just for example, if n is odd and we have to subtract, then we have to subtract what? Middle element, as it added twice, right? Just for example, so we have to check the n, right? If there is n, then we have already calculated, right? So n is divided by 100% or not, right? That is 0, right? So if it is not divided, means it is odd, right? If previously it is not odd, right? This is odd. So if it is not dividing and it's not giving the modulus 0, it means what? Remainder is not 0, it means what? This is odd, right? Our n is odd, so we have to subtract the middle element, right? Now we have to find sum. We'll do minus equal to what? Matrix at what? N by 2. Some element will come by n by 2. So we are not going to find the which element? N by 2 into n by 2 is what? See here. We have how many elements we have? 3. We are going to count 3 into 3 elements, right? Let's suppose we have total what? How many elements? 3 elements we have. Let's one at a time. So 3 by 2 if we'll do, it will become what? Almost 1, correct? Similarly, if we'll divide this one, it will become what? 1. So matrix at 1 comma 1 is what? This 5, and that's why we are doing here. Okay, now come back to here. Okay, once if condition is done, we will return this for loop comment, we will return our sum. Can you see, right? What I have done previous, first of all we have to calculate the lengths, then we will take on sum, and then what we will do, we'll create one for loop, as you can see, and we'll create the first diagonal sum, second diagonal sum, and then we will remove that repeated overlapped you can say diagonal value, and then we'll return finally as a sum. Okay, so let me zoom little out. Okay, let me compile first. So output is coming 25 and it is 25. Okay, let me check what is the difference we have. Okay, we have done sum minus equal to matrix, right, divided by 2, and another we have taken n minus 1 minus I, and then another we have taken what? Sum equal to matrix at I into I, right? No, sorry, I'm sorry, we will not count this one here actually, right? Once this loop is completed, then we should do. Okay, we will complete sum, right? Otherwise the sum is not correct. Okay, yeah, submit this one. Okay, so this is working for me. Thank you guys. Thank you for watching this video. Please subscribe this channel for the more videos like this. Thank you.